In this lesson, we're looking at formulas and some substitution. So if we look at this example, it says if x is 2, y is -3, and z is 5, then evaluate. Remember, evaluate means to work out or to solve, find an answer. So we need to evaluate the following expressions. So what I'm going to do is I'm going to substitute in the letters everywhere in here. So between a coefficient and a pronumeral, there is a multiplication sign. So this means 2 times 2 plus 3 times y is -3, and then minus z, which is 5. I'm going to work this through in little sections. So this gives me 4. 3 times -3 is -9, and a positive and a negative make a negative, so that's -9, and then take away another 5. So 4 minus 9 gives us -5, and I'm taking away another 5, which is -10. In this one, I have x squared, so x is 2, so 2 squared plus y is also squared, so -3 squared. Now, I've specifically put that -3 into brackets because we need to remember when we square that number, I have to make sure I square the -3 and not just the 3. So 2 squared is 4, -3 squared is 9, so plus 9, which gives us 13. And the last one here, I have a root sign, and it's going to be 3 times x, which is 2, times z, which is 5, and then minus, now if we put those in brackets, if you wanted to put this into your calculator, if you do it all in brackets, it will make it a little bit neater for you. And then x is 2 and y is -3. Now, if you don't have a calculator, that's fine, we can work it out. 3 times 2 is 6, 6 times 5 is 30, minus 2 times -3 gives us a -6, and a negative make a positive. So I end up with this, which would simplify to 36, and the root of 36 is simply 6. The next example uses compound interest. So our compound interest formula is A equals P1 plus R to the power of N. P is the principal amount that we invest, so how much money you have. R is the interest rate, and it's written as a decimal. And N is the number of years. So we want to find A, the final amount of investment of $5,000 after 4 years at 7.2% per annum, which means per year. So per annum means per year. So the first thing we do is we write our formula. We always write a formula because sometimes that can give us a mark, not all of the time, but it's about making sure that we understand what the question wants. P is my principal amount, which is my 5,000. 1 plus, now this interest rate, I need to put this into a decimal. So if I think I have 7.2%, if I need to make that into a decimal per annum, I'm going to divide that by 100. And if I divide that by 100, I get 0.072. So 0.072, and N is the number of years, which is 4. Now, all I need to do is put this into my calculator. So 5,000 times, so remember between a number and a bracket is times, 1 plus 0.072, close our bracket, to the power, which is this x to the power of y. That means we can put any power we want, and equals. So we get $6,603, and then it will be to 12 cents, so 0.12. So 6,603, 12, and that's to 2 decimal places, which is the same as to the nearest cent. This second or third example, is talking about exact dosage. So the exact dosage of medicine for babies is based on their weight or age, and there are different formulas for calculating this. So there are 3 formulas that we're going to look at. We have Fry's rule, Young's rule, and Clark's rule. So in the example, it says Sam is 15 months old, weighs 11 kilos, and the adult dosage of the drug is 20 grams. So we need to calculate Sam's dosage using Fried's, Young's and Clark's rule. So with each of these rules, we are going to write the formula. So we'll do Fried's first. So we want the age in months, so she is 15 months old, over 150, and we times it by the adult dosage, which is our 20 grams. And if we put that into our calculator, we end up with 2 grams. Then we'll do Young. So for Young, it's the age in years. So you need to calculate, well, what is 15 months into years? So we go 15 divided by 12, which gives us 1.25. So 1.25, and this is over the age in years, so 1.25 again, plus 12, and then multiplied by that adult dosage. So a little bit more complex. If we put that into our calculator, we get 1.89 grams, and I've rounded that to 2 decimal places. And then we have Clark's rule, which tells us we have the weight in kilograms, which is 11, multiplied by the adult dosage, which is 20, and divided by 70. And if we put that in, we get 3.14 grams. So again, you can see there from each of those different rules, the dosage does change quite a bit.